Good morning. My name is Jesulonimi. I'm the co-lead for Eternity ækiti. And in this short tutorial, I'll be teaching you how to create a smart contract using the Sophia programming language. So, for this particular contract we'll be creating, let's assume that we've had this problem of several librarians coming to complain and saying they need to keep good record of the books that come into their library, because severally it seems like some of them just start disappearing, and they want to know if it's a problem with database or if those books are not bought at all. And that's like what we'll be creating. So we are going to assume that several librarians can come here, they create a contract, and they can register their own books for their own specific libraries on the blockchain. So for this, I'll be using Fire Editor for this particular tutorial. Now, Fire Editor is the new IDE for the Sophia programming language. And okay, yeah, so this Fire Editor here, these are your accounts here. These features that are connected to the testnet presently, and these are you deploy your contract. Then you can scroll down. This is where you see your event logs, that is if let's say a call was successful or a call failed. So for a start, we are presented with this particular contract here called the crypto hamster contract itself. So what I will do now is I will control A, and I will actually delete everything here. So let's start from scratch. So now when you're writing a contract, the first thing is the keyword contract, CRACT, then CRACT, then the name of the contract. So you can see name of contract, then you can equal to sign, then an indentation. Now this particular name of contract just signifies that will be the name of the contract we are creating. And in our own case, now what we are creating is a book library contract, LIBRARY contract. Good. So we have is equal to sign. Now whatever we're writing now signifies what we actually want to be embedded in our contract. If you are coming from an object-oriented programming language like Java, you can imagine this as the class, then whatever I write here as the body of the class itself. So for a start, let's look what are the informations about our book that we would like to actually store on the blockchain. The first thing is that actually means that we have to create a record. So I'll say record book info now, book info, and I'll say it's equal to this, then this, then I'll come again, I will indent a little bit. Now I'm indenting because Sophia follows the block style of Python, that is when you write new code, you have to indent to show that it's under a particular block of code. So I'll come here now, I would say the first attribute is going to receive is the name of the book itself, and it will be of type string. Then I will come down, I will say okay, every book has something called an ISBN. So I'll say ISBN, and it's going to be of type string. Now at the same time too, want to record the date that a particular book was actually put on the blockchain. So I'll say dates, and to actually be of type string too. Good. So in case you're really confused about what a record is, you can think of it, if you are coming from JavaScript, you can think of a record as an object in JavaScript. So it has attributes, and it can store various values inside it. So we have a name in our record, we have an ISBN, we have a date in our record. So I'll come down here now, I will say okay, now this is where we begin to get very serious now, because now we need to talk about what we want to put in our state. Now whatever we put in our state represents all the data that we want our blockchain or our smart contract to actually keep track of throughout its lifetime. So now I'll come here, I'll say record, then I'll use the keyword state, and I'll say it's equal to this. So now inside here I need to define the data that I want the blockchain to actually keep track of. And now we already said that okay, we want to store this book info, but we will not specify the data structure we would want to use to store the book info. For me, I will say I'm going to actually use I'll use a map. Then this map will actually map a list of book info object or book info record in this case now. Then it will map it to an address. Good. So with this now, a user can actually come. So it's going to be book librarian, BRERIAN, then of type map, that's a map of a list of book info to an address. So like this now, a user can come, he would actually add his own list of books, and it will store the key will actually be his own address. Another user can come to, it will add his own list of books, and the key can also be his own address. Good. So we are here. Okay. So I'll now come here, I'll say stateful. Now I want to begin to create the function that will actually put a book in our state, or put a book in our contract, register a book in our contract. So I'll say stateful entry point register book. Yeah, I'll do this. I'll say is equal to this. Now I'm using the keyword stateful because this particular function is going to change the data in our states. I'm also using the keyword entry point because we are going to actually call this function from outside our contract, and I'm using the keyword register book. This is just the name of the function we're actually creating. So I'll come down here and I will say stateful entry point register book. The first thing I need to actually do is to get the list of book of this user. So I will say let users, let's just say librarians list of books now. Okay, let me leave it as users list of books. Then I'll use a particular function, inbuilt function of Sophia. It's called map.lookup underscore default. So now I'll say this now. So now I'll look up underscore default. Then what it's simply going to do is this function will enable us to check our map in our state if a person with a particular key of this address actually exists, and to actually return the data. And if it does not exist, what allows us to do is also it allows us to return a default value in case it does not exist. So I'll say my lookup underscore default. Then the person will be call.caller, which will be caller will hold the present public address of a person actually using the blockchain at that moment. So if I say I am on my own phone and I'm using the blockchain, call.caller will be my own address at that time. So call.caller comma then state. This will now be the map we're actually trying to check for a particular set of data. Book librarian. Good. Then the last thing would actually be the default value in case it cannot find a list with this particular key in our state, and the default value will be an empty list actually. Good. So we are here. Good. So far now we've done this and we've come here, so we've been able to actually get the list of books that the user has previously, and if it does not have anything, we actually return an empty array. But we need to also specify we need to allow this function to actually take in the parameters that we'll use to create or register a new book, which should be name. Now I'll be using this colon, like a single colon, to just make sure we know that it's different from this one here. So it's a particular style of programming. Sophia try. So I'll say ISBN colon then of type string. Good. Then I will put a comma again and say dates, then colon string. Good. So now from here again, I can now construct a new instance of our record object itself, or of our record, of our book info record. So I will say new book info is equal to, I will now say okay, yeah, normal brace, then I will say name is equal to name colon, then I'll put a comma, I will say ISBN is equal to ISBN colon, then I'll put a comma and I'll say dates is equal to dates colon. Good. So we are right here now. So now we're not going to actually have to add this new book info into our users list of books. Good. So I can come here now, down here now. Now the way you do this in Sophia is it's a functional programming language, and this particular users list of books is immutable. So we cannot just say something like probably users list of books dot add or something like that, and it will automatically add a new book info into it. No, we cannot actually do this. What we'll actually do is we'll create a new variable now. I'll say let new list of books now. New list of books. Our let new list of books is equal to, now this is how you add to a particular list in Sophia, new book info colon users list of books. Good. So when I do this now, I will come down here, and now what this line of code just simply does is it will add this new book info into this users list of books, and it will actually return the value, and I store the value as new list of books. So but you must know that this users list of books is not actually modified. That is, the data here does not change. Actually, data in users list of books does not change. Good. So let's come back here now. I'll use my put function now. I'll say put then state Now this is how you actually modify your state in Sophia. Use the put function. So we use the put function and we'll say put state, then you'll use a curly brace, and the put function is this is the function that you must use to actually put any data in your state actually. So I'll say put state, then I will access my book librarian in my state record, book librarian, and for me I will access call.call, which as I explained earlier holds the parent address of a person using our smart contract at the moment. So I'll say it is equal to new list of books. Good. So we have this now. So now let's create another function and that will actually get the list of books that a user has registered from the block, and I'll say entry point get users list of books. List of books. Then I will say this now. Say it is equal to state dot book librarian, then call.caller. Good. So now we have this already. So this function registers a book. This function registers a book. This function gets the books that were registered. But even now, apparently, our contract will not even deploy like this. As you can see, it's telling us that we need an init function. Now, an init function is a function that just states the default values of our state actually when our contract is deployed. So it would actually, it's a function that will actually store the default values of our state when our contract is actually deployed. So now we'll say stateful entry point init, and I'll do this, and I will say it is equal to, now it's going to be equal to a new instance of our state as I said. So book librarian equal to an empty map. So now we have this. So now we can actually deploy our contract now. When I click on deploy, this is patient, it might take a while. Good. Okay, good. So we have it here now, and I'll do this. I'll say book library. So now can you see now? It will, when I clicked on it, it gave me two options. An option to register a book. So now I can say, okay, our first parameter here was the name of the book, the ISBN, and the date. So let me say the name is a man called God or something. So let's just give the name. You can see the ISBN is 1 2 3 4 5 6. We can see the date is February 9, then 2012. Good. So I can send transaction now, and it might take a while now. Let's see. Good. And can you see this place now is holding the values of our event logs and it's telling us call successful. Now can you see again we have a call successful. So now let me try to get users list of books and let's see what happens now. So okay, so can you see now I got the dates, the February 9, the ISBN was, and the name was this. Now this particular things you see here, let me do this again. The particular things you see are the names of our functions here. So we had the register book function, we had the get users list of books function soon, as you can see here too. So and that's how simple it is. So let's add another book again. Let's call it I am there or something. Let's just be creative here, and let's see if let's add another number to it, and let's say this one was happened in December, DECMBER 8201. It's good. So let me send transaction again now, and we'll see if it will be added to our new list here. Good. So okay, it might take a while depending on how good the connectivity is. Okay, yeah, good. So we have it now, so I can get the list of books again. I can added it here. This was the first one here. This was the first data we actually stored, and this is the second data we actually stored. Good. So we have it here. So now our contract successfully registers the book and successfully gets the books that was registered. So now let me tell you how this works now, because I said earlier different people can actually use this contract and they will store their own list of books. So it's not just a one person contract per se. So I'm to talk here and I change my account or my public address on that public address, you will see that. Okay, good. So now what I will now do again is I'll register a new book now for this user, and I will call it there is hope for the future or something. There is hope for the future. That will be the name of the book. For the future. Good. Then the ISBN might be probably 15679 or something. Then I'll say this one was registered on March 4, then 2018. Good. So I'll send transaction now. Okay, good. So it has finished running that call. Then I will click on call local and I forget to ask list of, and it will not actually return the previous data of that person. It will return the data of the person who just stored something on the blockchain because we changed the address. So you can think of this person as a new librarian or something who wants to actually use our contract. So when I click on call local now, let's see what the result is now. For instance, now date March for 2018 SPN data for the future. Good. That's because we're using a new user and we change the address. So if I come back here again and I do this again now, and okay, good, and I click on call locally for get users list of books. Good. So now this is perfect. This is actually working, and this is what we want. Good. But there's still a gotcha here, and that is the fact that if, for instance, a user has not added a book to the contract actually, and it clicks on get users list of books, it would actually result in an error. So if, let's say I'm toggle to this user now, and okay, so I'm already in the user. Good. And I click on get users list of books now, it will actually create an error, and you guys might see this. So call error / aborted. Now the problem is that user, there was no actually key of that particular user in the blocking and in our smart contract at that time, so it actually give an error. So what we can do is we'll say map.lookup underscore default, then we'll say call.caller, then we'll say state.book librarian, then we'll give the default value of an empty list. So in case it ever happens, just return an empty list. So let's test this again now. Good. Okay, let me close this. Okay, so our contract has actually been declared, and this is it here. So now let me try get you that list of books, and let's see if we actually give an error. Okay, good. So now it does not give an error, so we are good to go, and that's our contract for you. So thank you guys for joining us on this tutorial video. We are glad to have you with us, and we hope you can actually ask your questions to get feedback and stuff. So thank you, give us feedback and stuff. Thank you, we're really grateful. Yeah, bye.